As you can imagine, there are many, many applications for finding the integral of a vector valued function, and we'll see those in the coming sections. But right here, we're just going to have one little example, which is we're going to find r given r prime. And we learned that we could do this in Calculus 1. So if you remember, the fundamental theorem of calculus, which I referred to in a previous video, was something we learned in Calculus 1. And it tells us that if we have the derivative and we take the integral of that derivative, we will get the function back, i.e. the antiderivative. That's the fundamental theorem of calculus, right? That essentially derivatives and integrals are opposite operations of each other. All right, and this particular example, by the way, is just a little bit of something called differential equations. We're learning how to find a function given a differential, given a derivative. Okay, so let's put a box around that. That's important to know. Should have seen it somewhere. I'm sure you have. Okay, so let's find the integral of r prime for our problem. Dt. That would be the integral of. All right, I'm going to take t, and we always don't like square roots written like that for the sake of derivatives and integrals, so we're going to rewrite it as t to the half, the negative pi sine of pi t, and then 3t to the negative 1. Okay. So the integral of the first piece, we add 1 to the power, so it becomes t to the 3 halves. And then with fractions, it's easier instead of writing divided by 3 halves, which it is, but that's kind of awkward to write. So we multiply by the reciprocal. And it's still a vector, so I still have to put my vector there. All right. Now, for sine, the integral of sine is negative cosine, or excuse me, it's positive cosine, right? So because the integral of cosine is negative sine. So this will be positive cosine. And then it would just be that, right? Because what's going to happen over here is you'd have pi and you would divide it by pi and they would cancel, right? So the thing about, in other words, we're doing a little tiny u sub in my brain. I'm thinking, oh, u is pi t, so then du would be pi dt, and therefore 1 over pi du is what I'd be. Right? So 1 over pi would be down here and it would all cancel out. So it'd just be cosine. And then for the back piece, well, that's 3 over t, and we learned that when it's just plain fraction with just t on the denominator, that'd be 3 natural log of the absolute value of t. Plus, of course, some constant vector. All right, this is kind of ugly, so let me write that again. So 2/3 t to the 3 halves, cosine of pi t, 3 natural log absolute value of t plus c. That's the integral. Now, it's not quite what they asked us for, but we're getting there, right? So r of t is related to this, but there's a constant over here. All right, so we have to use the initial value that they gave us. They gave us that r of 1 is equal to 1, 1, 1. This is called an initial condition. They're telling us that, hey, when, t is equal to 1, this is what your function value will be. So we're going to have to use that initial condition. Oops, sorry, I hit my thing, hit my camera here. So we're going to have to use the initial condition to solve for the c vector. Okay, we can do that. So remember that this initial condition is t equals 1. So I can say r of 1, I'll do it right here, r of 1, which is 1, 1, 1, would be equal to, that's a 1 right there. I know it looks like a t, but I meant to write a 1. Right, so r of 1, which is 1, 1, 1, is equal to, now I'm going to take this piece that I found, 2/3 times 1 to the 3 halves, cosine of pi times 1, 3 natural log of the absolute value of 1, plus c. And I'm going to solve this for c. So this is 1, 1, 1 is 2/3 -1, and the natural log of 1 is 0, plus my constant vector. And then I'm going to subtract this vector from both sides. So I'm going to minus the 2/3 -1, 0 from both sides. Over here, they're going to be gone. That's why you're doing it, because you're going to have nothing but the c vector left. So 1 take away 2/3 is 1/3. 1 take away a -1 is 2. 1 take away 0 is 1. And now I know my constant vector. So I can put this all together and say that r of t is equal to 2/3 t to the 3 halves, cosine of pi t, 3 natural log absolute value of t, plus 1/3, 2, 1. That's kind of awkward. It's not usually how we write these, so let's put this together. This is 2/3 t to the 3 halves plus 1/3, cosine of pi t plus 2, and 3 natural log of the absolute value of t plus 1. Hooray for the fundamental theorem of calculus and being able to find the original function given the derivative.